Hello friends, today I will discuss another topic, that is basic laws of Boolean algebra. Okay, so Boolean algebra we have already discussed, that is different postulates, rules and regulation of Boolean algebra we have already discussed in the last lectures you see. And another is today I will discuss basic laws of Boolean algebra and some whenever you go through different operations or that is we can tell as addition, subtraction or anything through Boolean algebra, then a few rules also implemented or proved through logic gates. Some logic gates also we apply to operated to operate the Boolean expression or Boolean algebra. Okay, so Boolean expression are defined through different operations, but that expression how it is true through different logic gates, the using different laws we can tell as like a commutative law, associative law or distributive law. Like this we will discuss those laws under Boolean algebra. Okay, now we will start that different laws under Boolean algebra. Okay, so now we will see that what is the Boolean algebra, what kind of definitions also there in the Boolean algebra. We know that suppose we go through Boolean algebra. So definition we can define like a certain relation we have to create, that is a Boolean function f. One is a Boolean function f and a binary variable and a binary variables. Okay, and a binary variables, we just create a relationship among with a Boolean function and a binary variables. Okay, which is represented by that is one kind of table. We can tell as the table is a truth table. Okay, that means we just create a relationship among Boolean function and binary variables to make a truth table, which is defined under this Boolean algebra. Okay, it is the one concept also we will consider, because Boolean algebra only not only we will design or define the Boolean algebra, also we create some relationship among Boolean functions with certain variables. Okay, that will be defined through truth table. And algebra, if we go through algebra, means Boolean algebra, if we go through algebra, okay, if we go through algebra, this algebra deals with some certain variables, means binary variables. Okay, algebra deals with binary variables and some logic operation and logic operations. Okay, algebra deals with the binary variables and logic operations. So whenever this kind of algebra defined, we can tell as we can call as Boolean algebra. Boolean algebra. Okay, that means algebra which deals with the binary variables and logic operation, we can tell as a Boolean algebra. Okay, so this is some definition we can define. So first of all, we just make some relationship among Boolean function and binary variables which create which create that relationship in truth table. Okay, we can tell the truth table. Once a truth table will create, that means it relates the relation create among Boolean functions as well as binary variables. Okay. So similarly, whenever Boolean algebra defined, that means algebra deals with the binary variables and logic operations. These two things we will consider. Okay. So now we will see that some laws and some rule and regulations of that is Boolean algebra. Basic regulations we will see. After that, we go through that other rules. Okay. Let us consider that is AND operation, okay. Another is OR operation, next is NOT operation. Okay, three operations we just consider. Then we see what are the axioms we will consider, then what kind of axioms are there, how it deal with these numbers. Okay, now we see. So first case we see here case 1 or axiom 1, suppose we take like AND. If we go through AND, then what happens? Very simple. Suppose 0 we consider. Okay, 0.0 is equal to 0 for AND operation. Okay. Similarly, if we go through same 0 also use for OR, what we write 0 plus 0 is equal to also 0. Okay. We consider in this way. If in NOT operation we will consider, suppose NOR operation, then what happens? Same 0, suppose we got NOT, that is 1. If we okay, if we consider 0, that is not 0 NOT, that is 1. Okay. In this way we can also define the different axioms. What kind of axioms we will see. Different axioms are there. And another is similarly axiom 2. Very simple way. Initially we took that is 0 0, means two variables, one variable for 0, another variable also 0, when two variables 0 0. Similarly here is 0 1, 0 1 also 0, 0 plus 1 is also 1. Okay, here we will take already 0, we can take here 1 complement, that is 0, no problem, as you like you can take it. Okay, this is axiom 2. Suppose axiom 3, then what happens? 1 0 is equal to 0, 1 plus 0 is equal to 1. Okay, that's all, because already 0 complemented, 1 completed already taken, no need to write here. Then axiom 4, that is 1.1 is equal to 1, 1 plus 1 is equal to 1. Okay. So like this. So different variables. Why I am telling? Because you see, whenever you go through different truth table, then you just make some relation among Boolean functions and binary variables. So binary variables we can take a 0 1 1 0, whatever the binary variables, and Boolean functions also find out what is the output or function defined how. Very simple. If we go through Boolean functions, so f can be defined, see, very simple, x dot y. Here f defined x plus y, very simple way. The Boolean function f define x dot y, x plus y. Here very simple, f define x complement, whatever the value we can take, x complement. So in this way different operations and its corresponding axioms also we can consider, and we can prove it through certain that is we can tell as a truth table. Okay. Now see how other part we can define. Okay. Let us consider like a basic laws. We go through basic laws. Basic law means here basic law of Boolean algebra. Okay, basic law of Boolean algebra. Basic laws of Boolean algebra. Okay. So basic laws, if you define basic laws, very simple laws we can consider. One is a commutative. Okay, commutative. Commutative in say two operation we can commutative laws. It is defined under one is a addition. Okay, another is a multiplication. Okay, one is a addition, another is a multiplication. The two ways we can define. Okay, another is associatively. Associative laws, both addition and multiplication, that is also we consider. Okay, and third one is that is distributive. Third one is distributive law. Okay, above three laws, not only it is a basic laws, other laws although there, but we consider these basic laws and we will define the design these laws with the help of some certain logic gates. How logic gates is helped to prove it. These laws is that is defined under this Boolean algebra. That is we have to prove it. Okay. Now we start our work how it is defined and designed for individual laws for Boolean algebra. Okay. First we see that is a commutative laws. Okay. This commutative law, let us see that how it is defined. Okay. So commutative law for addition. First we see for addition. For addition, very simple way. Commutative law for addition means x plus y is equal to, that is y plus x. Very simple way. All of you know that, I think. Okay. X plus y is equal to y plus x. Now prove it how it is both equation or both expression is equal through logic gates. Very simple way. I will show it. You see, this is if we go through x plus y, definitely we go through OR gate. Okay, very simple way. We go through OR gate. That means two variables we consider. One is x and y. Okay, this is x plus y. Whatever the value we got it, x plus y, here we can get, that is x plus y, which is equivalent to, we can define that to that is what reverse case we defined here, y and x, here we can find y plus x. Okay, both are equal. Okay, this x plus y is equal to x or y, that is x plus y, which is equal to y plus x. Okay, this is for, that is addition. So OR gate we can take it. If we go through multiplication, then another way we can write for multiplication. For multiplication, what you write? Obviously, we can define, that is what you write? We can define in this way: x dot y is equal to y dot x. in this way we can define the multiplication. Okay. So then how to that is defined, since it is a multiplication, we know that for a multiplication AND gate we can consider. So AND gate, very simple way, we can take AND gate x y, here is x y, okay, which is equivalent to, that is a reverse case also we can define, like y, here is x, here also y dot x. Okay. So in this way both x dot y, y dot x, both are equal. So in this way we can define the commutative law on addition and subtraction, both also we can define. Okay. Next, this is the, that is commutative law. Next is associative law. Okay, we will see that is associative law. Now test it. Second one is associative law. Okay. So similarly associative law on addition, we can take on addition how it is defined. Okay. For addition, okay, for addition how to define, that is x plus y plus z, okay, x plus y plus z is equal to x plus y plus z. It associate y plus z with x, here x plus y with z, associate defined in this way. Okay. Now see the logic gates also we apply for this associative law. What is the logic gates? Okay, you see here, that is OR gate we can take. Again associated with the x also we can OR gate, both are OR gate we get, because it, since it is a addition operation we will consider though, so OR gate we can consider. So now we start here, you see first you take, that is two variables, that is y z, okay, two variables y z already already designed. After that add with x, what is the value of here, okay, because here value is y plus z, then this value is consider with another OR gate, here is one value, another value also we can take here x. Okay. In that case what happens, the result will be x plus y plus z, because y plus z is here, add with x we can get this. Okay. This is the basic concept. Okay. And we have to show that which is equivalent to this one. So now we see second part, which is equal to this one. Now second part I will draw. Now first of all x plus y, x plus y, okay, x plus y in this way, one is x, another is y, okay, and this result is x plus y. So it is also defined another, here is z, here is z. So last result is x plus y plus z, okay, x plus y plus z. So this is for addition. Okay, this is for addition. For addition, x plus y plus z is equal to x plus y plus z. Very simple way. Okay. For multiplication, next for multiplication. For a multiplication, what you write? Very simple way. X y dot z is equal to x dot y dot z. In this way we can define. Okay. Now you see how it is defined. Very simple way. X first, here what happens, we write, that is we use that is AND operation. Okay, because AND get we will use, but here is a OR get we use, because since it is a multiplication, so AND get we will use. First of all, similarly yz. So write yz here very simply. Here y, here z, yz. So again here also define this one. Another is a x. Here is a x. Okay. So here is a yz. Okay. Here is a x dot y dot z. We define in this way. Okay. So which is equivalent to this one, which is equivalent to this one. How? This is a like a y plus z, sorry, y into z. Y into z means we write here one is sorry, here is xy, here x, here is y, xy. Okay, x dot y. Next z. So we write in this way. Here another is z. We write z. Okay. So here x dot y dot z. We can define in this way. Okay. So which is equivalent? X dot y dot z is equal to x dot y dot z. In this way we define the associative law. Okay. So now last one is that is a distributive law. Okay. So define distributive law. Third one, distributive law. Okay. Third one, distributive law. Distributive law means x into y plus z is equal to xy plus xz. We have to prove it like this. Okay. X into y plus z is equal to xy plus xz. Now see yz. Yz is a OR get, is a very simple way. OR get, we take OR get to variable, that is y and z. Okay. This is one part. Another part is AND get. AND get here, because this is y plus z, another part is AND get. So x, another variable, come to here like this. So here write x into y plus z. Okay, x into y plus z. This is the one. So which is equivalent to, we prove it, that is xy, another is xz. Okay, xy, another is xz, which is equivalent to this one. Very simple. Here write this one, 2 AND gate we consider, because 2 AND gate x, y and y z. One is x, another is y, here is z, another here also consider for here, no problem. Okay, x, here is x z, here x y, like this we consider. So whatever the output we can get it, here we can find out. Here is x y, here is x z, and both after getting x y and x, y z, then it will add. Okay, when it will add, then OR gate we can take, OR gate. Okay, this is OR gate. So what is the result? Here result is x y plus x z. Okay, x y plus x z. So in this way, different data we can also define, different laws, different rules we can define. Okay, so both this part and this part equal, this part equal, so each equivalent symbol also I used to define, to design this individual part. So how different logic gates we consider, we defined through or for different laws under algebraic or Boolean algebra. Okay, we know that Boolean algebra, what are the rules, but how those rules defined through logic gates. Okay, that is designed here. I also took those different logic gates to prove for the different laws of Boolean algebra. Okay, that is the important part of this Boolean algebra. We can also analyze theoretical, but how logic gates used to prove it that our law is true through logic gates. Okay, so thank you very much to watching our this videos. Thanks to all, and that is please subscribe my channel. If you want to give some comments, you also give some comments. Okay, I hope all of you understand very simple way I defined or designed this kind of a concept, that is basic laws of Boolean algebra. Okay, and the next lectures I will also use that is different types of rules, various different rules under Boolean algebra with different applications, that I will tell in the next lectures. Okay, so I hope all of you understand this particular lectures videos. Okay, thanks to all.